This quick guide video explains the content of the EyeSeeSix report, which can be generated after performing video head impulse testing. The EyeSeeSix report provides clinicians with a single-page overview displaying the results from all 6 semicircular canals after eye movements in response to head impulses have been recorded using the EyeSeeCam. In order to generate this report, you need to complete at least one run of each protocol: lateral, RALP, and LARP. If you choose to run a protocol more than one time, then you can use the check marks to decide which run from each protocol you wish to display in your EyeSeeSix report. The report focuses around a gain plot displayed in the center that shows VOR gain for each of the semicircular canals. The gains shown for the vertical canals are based on regression analysis, while the lateral canals show both regression-based and instantaneous gain measures. Instantaneous gain has been validated as the gold standard for vestibular ocular reflex measures and evaluates the difference of eye velocity to head velocity at 3 particular times: 40, 60, and 80 milliseconds. The EyeSeeSix report displays the most commonly researched time of 60 milliseconds. The regression analysis, on the other hand, takes into account the relationship between head movement and eye movement for all accepted head impulses between the time frame 0 to 100 milliseconds and provides a single value which represents the average VOR gains through calculating the regression slope. The regression analysis ignores data points after 100 milliseconds, as after this time, eye movement is not solely regulated by the vestibular ocular reflex, and contributions from the visual system, such as smooth pursuit and optokinetic eye movements, occur. Once these gain values are established, they are plotted within the polar gain plot. There are dotted grid lines within the plot, each marking a measure of gain. This plot gives an overall visual of where each of the gain calculations is plotted in relation to unity gain of 1. In a normal, healthy vestibular system, you would expect to see gains measured using instantaneous gain to be near 1, and an impaired vestibular system may show gains of less than 0.79. The black dot represents the actual gain value, and the black bar around the dot represents the standard deviation for the measure. Surrounding this gain polar plot are the raw data tracings for eye and head velocity. The traces display head movement and eye movement. Head movement traces are shown in red if they stimulate a right-sided canal, and in blue if they stimulate a left-sided canal. The eye movement tracings are then overlaid in black. You can use these traces to detect the presence of both overt and covert saccades. This is important as this information cannot be derived from the gain value itself. Adjacent to the raw tracings for each semicircular canal is the regression plot. This allows for the clinician to look at the gain over the entire velocity range of head impulses. Lastly, displayed in the center of the report is a plot which provides information on how accurately the vertical canals were stimulated in their respective planes. The dotted lines show the correct plane of stimulation, and the grey lines show the actual plane in which the canal was stimulated. For accurate measurements, it is important that the grey lines fall on top of the dotted lines. The EyeSeeSix report allows for simple interpretation of complex information and is presented on a single page. It is unique to the EyeSeeCam vHIT system. This concludes this quick guide video which explained the content of the EyeSeeSix report.